Hi everyone, in this video I'm going to go through an example of a process we call taking logs and derivatives. And what we do when we take logs and derivatives is we find an expression for the growth rate of a variable and decompose that growth rate in terms of its component parts. Now in this video I'm going to focus on just this variable here. We have small or little k, which is equal to big K, that's our level of capital in our economy, divided by big L, which is our level of labour. So small or little k represents our capital per unit of labour. Now the first thing that I'm going to do is just take logs of both sides of this equation. So we get the log of small k is equal to the log of big K minus the log of big L. I'm just using the quotient rule here. I've written it up here. The log of any a over b is just equal to the log of a minus the log of b. Now I should say I am using the natural log here, so ln. I have seen textbooks discuss this stuff and they use the word log instead of ln. In these cases, we can take the discussion to be about the natural log, so log base e, which is equal to ln, but the authors are just suppressing that subscript e because it's just such a common function to work with. Since we're thinking about growth rates, we're really essentially interested in understanding how our variables behave over time. And these variables, our big K, our big L, and our little k, they will change over time. So I'm just going to rewrite our equation, but I'm going to put t for time in parentheses next to all of our variables just to make it really clear in my notation that we can think of all of these as functions of time. The next thing I'm going to do then is take the derivative of all of my logs with respect to time. Now to do that, we are going to have to use the chain rule though, since we have, well, functions of functions. So we're taking logs, which is a function, of functions of time. I've written the formal definition of the chain rule just to the right here. So for some y that is a function of g and g is a function of x, if we want to take the derivative of y with respect to x, we need to set up two equations. The first equation involves defining u, which is equal to g of x. And then we can rewrite y is equal to, well, function of u. And this works because y is a function of g of x and g of x is equal to u. Using these two equations, we can find dy dx is equal to, we take the derivative dy du and we multiply it by the derivative du dx. Now back to our example, I'm just going to apply this process to the log of our small or little k, just to show you how taking the derivative of our logs with respect to time works. I'm going to start by defining y is equal to, well, the function that we're interested in taking the derivative of is the log of our little k of t. I'm then going to define u is equal to, well, little k of t. So little k of t is like g of x in our chain rule formula. That's my equation 1. I can then rewrite y is equal to, well, it's equal to log of little k of t, but little k of t is equal to u, so I can rewrite that y is equal to the log of u. That's our second equation. Using these two equations to find dy dt, we just need to find dy du and then multiply that by du dt. Now dy du will be equal to actually 1 over u, and I'm just using the rule for taking the derivative of the natural log down here. The derivative of the natural log with respect to x is equal to 1 over x. Y is equal to the natural log of u, so the derivative is 1 over u. Now u is equal to, well, little k of t, so I can substitute back in my little k of t straight away, and we get 1 over little k of t as our answer. The next derivative is the derivative of u with respect to t, which is actually going to be equal to the derivative of little k with respect to t. To understand why this is true, intuitively, when we're taking the derivative of u with respect to t, we're asking how does u change when t changes? Well, u is equal to little k of t, so the change in u will be equal to how little k of t changes, i.e. the derivative of little k with respect to time. All right, that's our derivative. Let's think about what we have here. I'm going to leave the first expression, 1 over little k of t here, and focus on that second expression, the derivative of little k of t with respect to time. Now this derivative is really just equal to, well, the change in our little k over time. In macroeconomics, we represent the change of a variable over time with a dot. So we can rewrite this as little k dot like this. I'll write this notation out down here for any variable, say x dot will be equal to the change in x over time, or the derivative of x with respect to time. Now this little k dot is multiplied by 1 over little k of t, which is the same as dividing by little k of t, so we get this fraction, the change in little k divided by, well, little k, and often at this point we just remove the parentheses of t here, it's really not needed. This fraction, the change in little k over k, is really just equal to the percentage change in little k, or rather the growth rate of little k. So we've shown that when we take the derivative of our logs with respect to time, we get back, well, growth rates. So just recapping, if we take the derivative of log of little k, we get the growth rate of little k back. If we went through the same process with the log of big K, we will get the growth rate of big K back, so big K dot over K. And same with our log of big L, once we take the derivative with respect to time, we get the growth rate of big L back, that's L dot over L. So we've ended up with this expression for the growth rate of little k being equal to the growth rate of big K minus the growth rate of big L. And so by taking logs and derivatives then, we get this decomposition of the growth rate of our little k in terms of its component parts. Now this technique is used quite a lot, especially in macroeconomics. Apart from the application of the chain rule, you will also need to know your rules of your natural log here. And for instance, you might get a variable that is a multiplication instead of a division like I've worked with here. You will have to do some slightly different things, but the general framework is still the same and you'll be okay as long as you know your rules of your log. That's it for this video though. I do hope that it helped. Thank you so much for watching. Please like and subscribe. Have a good one, everyone.